Hello, I'm going to walk through Lesson 7 of the Marlowe Starter Kit. This lesson shows how to check the safety of a Marlowe contract. Now, Marlowe tools provide several safety checks. You can use Marlowe Runtime's REST API, Marlowe Runtime's CLI, or the Marlowe CLI. All three of these do safety checks. They basically print the same report, but in slightly different formats. In this tutorial, we're going to use the first method, but we could have equally well used any other. One thing to remember is that Marlowe Runtime does not prevent you from submitting an unsafe contract. It gives you a report on the safety of the contract when it builds a transaction. If you don't like the information in the report or have concerns about the contract, then you should not submit it. So, and there's a little bit of guidance here in the report itself, because some errors will be marked as fatal to indicate that they're so severe you probably should not submit that transaction. Also point out that the safety analysis tools have not been audited, so they're here to help you, but they don't give you 100% assurance. So you really do need to test all the execution paths of a Marlowe contract on a test network before running it on the main network. We also have a couple of resources to understand the background behind these safety checks. First is the best practices guide, and this basically goes through a lot of techniques for working with Marlowe in the real life context of the Cardano blockchain. So what to watch out for, some things to make your contract more efficient, things like that. Then we also have a security guide, which gives you even more detail, and it basically goes through the security of different parts of the Marlowe ecosystem and how do you check things, verify things. So you might want to take a look at both of those. What we're going to do first here is walk through the tutorial. So this assumes that you've set up your environment for the Marlowe Starter Kit. We're not actually going to use any keys in this. We're just running analyses, not running things on the blockchain. So we did the preliminaries. And now what we're going to do is create a first example contract. And so I've created this contract basically to be unsafe in several different ways. So I'm doing things like mixing testnet and mainnet addresses. I've got names that are too long or garbled policy IDs, things like that. But we're going to create the JSON file for that. And then since we're using Marlowe Runtime via its REST API, we're creating a post request. So here's the request we've created that will ask Marlowe Runtime to build the transaction to create the contract. And then we'll actually run this and we'll take a look at the response. So Marlowe Runtime gives us a long response here. It contains this list of safety errors, and we're going to go through these one by one. So if you have a lot of errors, you'll get a lot of output. And then, of course, it gives you the transaction body that you could sign and submit if you really wanted to sign and submit a contract that's this unsafe. So the next thing we can do is just, let's look to see what kind of errors we got. So we have 7 different kinds of errors. The first error is called missing role token. So let's pull that out of the response. So the error is missing role token. This is considered a fatal error. You'd be in big trouble if you submitted this probably. And then we have a little description. Basically, this is saying that the role token, a role token, is mentioned in the contract, but when we do the creation transaction, we're not telling Marlowe what the role's currency is. So in that case, the contract won't be able to operate these roles. The validator will fail on that. And you can see up here when we created the request, we created one role, or we told it about one role called an extra role here at this address, but we did not tell it about this other role that we're getting the warning on. So that's why we got that. So that's the missing role token. Basically, when you create a transaction, you need to tell Marlowe Runtime what the policy ID for the currency symbol is in the contract. And if you don't, you'll get an error like this. There's also this extra role token error. Now, this is not fatal. but it's something to look at. Like here, we are not using this token called an extra role in the contract, but we're telling Runtime when it creates the contract that we are going to use such a role. So basically, our thinking on the creation side is different from our thinking on the contract side. So we want to sort that out, even though the contract would actually run fine. But there's something suspicious here that you'd want to check. So you kind of have two things. This one role token, which has this really long name, was not specified in the creation request, whereas this extra one was specified, but it didn't need to be. So you get a report on that inconsistency. Now, the other thing is the blockchain for Cardano limits token names to 32 bytes. So mostly that's 32 characters, unless you're using Unicode or something like that. And we created this role name that's way too long. It's probably about 50 bytes. And so we do get an error here. And it basically tells you it's too long, gives you the name of the token. And this is considered fatal because if you tried to run this contract, you might be able to run some paths through the contract. Certainly the timeouts would work. But anytime someone had to present such a role token to the contract to authorize a transaction, that would be impossible because no such role token could actually exist on the Cardano blockchain. So you probably wouldn't want to run a contract like this. Invalid currency symbol. You may know that currency symbols in Cardano have to be 28 bytes long. So here I actually gave it a currency symbol in the contract that was too short. So once again, in the Cardano ledger, you could never have a currency symbol like this. And so you really wouldn't want to run a contract where it was impossible to have the currency symbol because none of the roles in the contract could ever work. There are other things we did wrong in this contract. We're actually connected right here to Marlowe Runtime, connected to the pre-prod testnet, but I put in the contract a mainnet address. And so that would be a big problem because if you ever executed the path in the contract that tried to use that mainnet address and you were running on the pre-prod network, the transaction would fail. It would actually fail phase one validation at the node because it's nonsensical to try to send funds to mainnet when you're on pre-prod. And so you get this wrong network. Once again, this is a fatal error. Any path in the contract that involved this address would not work. And then this other error is a little bit extra information where in the contract, I actually included both mainnet and testnet addresses. And of course, such a contract could never live on either of the networks. So the wrong network might catch a case where maybe you're developing on one network and then you try to deploy on another, and then the addresses are inconsistent or basically wrong. And then inconsistent networks, the contract itself, even without trying to submit it anywhere, is kind of incoherent. So basically, those are a few things that are wrong there. And then we have the seventh error, which is a transaction validation error. And this actually has happened in this contract because we really messed up in the other 6 errors. And so you could never submit this transaction to the node. And now, unfortunately, the node doesn't give you like a detailed report about why it rejects a transaction. So the safety analysis tool is not going to give you a detailed report on this, other than one of the possible transactions in the future of the contract or its creation transaction would not validate on the node. And that basically means a path through the execution of the contract is blocked. So this is considered fatal. And you can actually look, this is the transaction that was trying to be submitted. It was a choice or something. Actually, it was a deposit. This is basically what failed. And what failed here is there was no way to build such a transaction because this nonsensical token doesn't exist. And so the node choked on that. So you get basically what, at the semantic level, you're trying to do with Marlowe. Here's the contract, the input, the output that would occur if the ledger rules allowed, and the state, and then you're told that no, this failed validation. So let's look at another one. We'll create another contract. This has a couple more errors in it. We couldn't pack all the errors into a single contract, so that's why we're doing a second example. And then once again, we'll create the post request, and then we'll send that over to Marlowe Runtime, which will try to create the transaction, and then it'll give us a report. So here we have 5 errors. We already talked about transaction validation, so we're just going to look at the first 3. So missing roles currency. So what happened here? This is a role-based contract, because if you look at the contract, it includes roles. Yet in the actual request here, we did not tell Runtime that this has a currency symbol for the roles. So these roles could never be used because no such role tokens could exist. So basically, if you get this, you have a fatal error. You're creating a contract that uses roles, but you haven't actually given Runtime the information about the roles currency. Another one is this invalid token. This is a little bit obscure. This is the case where the policy ID is blank, but the token name is not blank. And such a token could never exist because it's using the ADA policy, and the only ADA that was ever created from that policy, the only thing that was ever created from that policy, was ADA during Genesis. There's no minting of that. And so, once again, this is a token in your contract that could never exist. And then we have an example where the token name is longer than the 32 bytes. So either the role name or the token name could be too long. In the previous example, we saw the role name being too long. Here's a token name in the contract being too long. So once again, a transaction involving this could never occur, so we mark this as fatal. Now the third example, let's just say that in making the request, we're still using the previous contract, but we actually put in a currency symbol that cannot exist on the Cardano blockchain. I think this one is too long, but we're telling Runtime to use a policy ID for roles currency that could never exist. And then Runtime will choke on that. It actually gives you an HTTP response. It doesn't give you a safety report. And it basically said it can't even parse that because that's a nonsensical string that we gave it. Okay, so here's a fourth example. This is a super simple contract. It's just the close contract. And then what we're going to do here is say that there's a roles currency for this. So we're sort of saying that this contract has roles, but it doesn't have roles. So we'll create that request, send it over to Marlowe Runtime, and we get a response. Contract has no roles. So that's very straightforward. It's just no roles are in the contract, but we're trying to create it as if it had roles. So this isn't fatal, but once again, it means that your thinking or your setup is muddled when you're trying to create this. Okay, here's the fifth example. And in this case, we're going to create a contract that's actually fine with the ledger rules, but it has a semantic problem. And let me just show you what this contract is. So we're paying into the contract with a deposit 50 ADA, and then we're withdrawing 100 ADA. So that doesn't add up. You can't withdraw more than you deposit. And you'll see in Marlowe Playground, you actually get a warning on this. The contract makes a payment of 10 ADA from account depositor, but the account only has 5 ADA. So this is not an unexecutable contract, but it's kind of a warning that wait a second, this is not really doing what you probably want it to do. If you simulate this contract, the contract will pay just the 58. Let's look at this contract in Marlowe Runtime. So there's that contract, and we'll create the request, and then we'll send the request over to Runtime, and we get transaction warning. And so let's take a look at this. And basically, it says a Marlowe semantics warning, so that's about the Marlowe language, not about the blockchain itself, is reported. And this is not fatal because you could run this, but it might not do what you really plan it to do. And it shows that, when we get further in the contract, there's going to be input that basically generates the warning. And if we look down here, we can see the warning right here, which is, such and such an account is asked to pay a certain amount, but it only paid this other amount. And that's the warning. And you could have caught that in the playground. Now, the final example is looking at a contract that is fine semantically, and it doesn't have any gross errors like tokens that have really long names or anything like that. But it's just too expensive a contract to run in one transaction. So we're going to create this contract. I'm not really going to go through all the details, but you can see it's big. So we have the contract, and then we'll create the request. And there's the whole request body with the contract. And then we'll submit that to Marlowe Runtime, and we get this transaction validation error. We'll just take a look at the first one. And so this actually does give you a message because this is failing phase 2 validation, which is when the Plutus script runs. And the key thing is this message here. We'll take a look at that. But essentially, we've got a particular transaction in the future of the contract. It's not the creation transaction. So several transactions in this contract would work just fine, but then the very last one would fail because of this execution cost. And that's why we use the analysis tools. We really want to know that every execution path of a Marlowe contract will obey the ledger rules. So we get the detail of this is the current state of the contract. This is what it was trying to do. In this case, it's making way too many payments at once. And then it had, an internal state here. It's giving us that. So it gives us full diagnostics. And the message that we get, it's a little bit cryptic, but the key thing is script execution error. And then you see script evaluation failed. The machine, meaning Plutus, the Plutus machine that runs within the node, terminated due to overspending of the budget. So this is really the key that's saying you're trying to pack too much computation in this one transaction. And then it gives you some numbers about how far it got. And we can actually see that it was the memory that it ran out of, not the CPU. But basically, we're stuck right here. So you don't want to be in this situation. You want to analyze your contract and make sure that you're obeying the ledger rules throughout all possible uses of the contract. And if you look at the best practices guide that I showed you, there's a very simple fix to a contract like this. So you have to basically split up the payments and things. And so you don't have to really despair, but you do have to pay attention to these ledger rules. There's also a situation where you might have a really large contract, and Marlowe Runtime just runs out of time analyzing it. So it can't really give you a thumbs up or a thumbs down. It just says, hey, it's too complicated for me. The reason we have this is that if you have a Marlowe Runtime instance that's available to the public, then people could actually spam it or do denial of services attacks on it by giving it really big contracts and getting it to try to compute all the errors in them. And that would tie up the resources on the server. So if you're running a private server, you can actually set this timeout number to a really big number. If you're doing this at the command line, you don't have a limit. So you can analyze larger contracts. I think the default is 15 seconds of computation that's allowed for this. but that could obviously be changed. And then there's some other safety errors that you could receive in certain contexts. You're basically not going to receive these in Marlowe Runtime, but if you're building contracts from scratch with Marlowe CLI, you could experience these. They're a little bit esoteric, so I'm not going to go into the detail. The best practices guide and the security guide actually go into this. But essentially, you could create an initial state for the contract, like so before it ever starts running, that is basically broken. It violates the invariance of the Marlowe semantics, and then the validator is going to refuse to operate that contract. So there's some kind of duplication in some of the internal state that one could do that this will catch. And then the Marlowe CLI analyzer will give you some sort of heuristic outputs where it estimates if there's a problem in the contract. It's computing based on bounds, not by exact values. So it'll give you these, and that's really only useful if you don't want to run the full analysis, but you want like a quick analysis of the contract. And it'll give you recommended values that are safe to use, but it won't say that you couldn't also have a safe contract with lower values. So that's a little bit abstract, but the only thing to remember is there are a few other safety errors you might experience. Basically, that's where we are. Thank you.